Okay, hi everyone. Today we will learn about distributed systems. So, as our application expands, that users' requests balances increase and strict data structures becomes changeable, it means our DB needs to be distributed, as we talked before, and it needs to be manageable at the same time, and it should be stable, of course. This is a main purpose of the distributed systems. In that system, we can work with multiple nodes with network communications, like not only the single server. It means data and software can divide or replicate multiple resources. Distributed systems can mainly decrease single point of failures, of course, and it can store big data and separate workloads. So, as we said, node is separate virtual machine in the system. It can be workload, it can be worker, it can be server, it can be follower, and it includes its own RAM, its own memory, its own storage, disk, and so on, and communicate each other with some kind of shared technique types. We will see in here some kind of shared techniques and its types, which are shared memory, shared disk, shared nothing, and some kind of things. So after that we will see that shared memories, shared disks, that techniques, communications, and after that sharding and replication we can see. So firstly, shared memory. It is a resource management technique that provides us a virtual unified address, like space for the independent nodes in a distributed system. It means all of the nodes work in a single RAM. In here, this is, for example, processors, or we can call it nodes. All of this includes just the one memory. That's why we can call it shared memory. So where is shared memory used in the database system? It can use mainly buffer cache, some kind of like the cache types, like includes mainly buffer cache and like the query cache and some network types. So buffer cache is it stores frequently accessed data pages from disk. And like, for example, instead of reading directly from the disk, directly from the DB, every time the database reads from the memory firstly. Like this results of the previously executed queries with, for example, we can usually say TTL, like it means time to leave, saves computation time, and after time expired, cache can clear it or get new data from the DB. Their main advantages are they are faster, of course, with the consistency, and easy to look. So this is a main concept of the shared memory. So some kind of there's some kind of drawbacks, of course, in here, and some kind of advantages, of course, for the shared memory. So main advantages are they're faster for consistency and easy to look, as we said. And if we want to scale with the multiple machines, we cannot it. For example, this is only one single machine, we can see. If we want to scale it with some kind of multiple machines, we need to create separately shared memory and separately some kind of multiple processors, multiple nodes, and it means we cannot. And for example, we have a single point of failure, that case. It means that if our one RAM, one memory fails, full system can be failed. So what else? Shared memory is the best for low latency, high speed applications where all data must fit into the RAM of the single machine. This is the main concept of the shared memory. So the next one is shared disk. Shared disk is, it can be allows the multiple independent compute nodes we can see in here. That multiple nodes can independently compute to directly access a single centralized disk. This disk is centralized in a single. The main difference between the shared disk and the shared memory is each node can read and can write to this common storage, and making it popular for highly available databases with clusters for shared disk. It means a single way, we can say, separate RAM, separate nodes, and separate some kind of processes or caches in here we can see. So how it works? Let's imagine we have four shared memories in here, for example, 1, 2, and 3, and 4 nodes. So all of these run database instances, and all of these connect to the same disk storage, we can say. And they can read the same tables, and they can write the same data to the one single disk. So shared disk techniques is the best for systems where reliability is more important than massive global scaling. Reliability is more important than the scalability. So if our service dies, the main advantage point is if our some kind of service or some kind of node fails, others can be worked continuously. So one, and of course they are good at with easy to data sharing as well, because data is stored in one disk. Some kind of drawbacks. So the drawbacks of the shared disk technique is firstly data cache consistency. It means each node has its own buffer cache, as we talked before, and its own RAM. The problem is they may have different copies of the same data, its own buffer cache. What's going on wrong? What can go wrong in here? Node A updates in a row. For example, this is A, B, C, and D nodes. For example, node A, let's imagine, updates a row. Node B still has an old version cache. This is, for example, new cache. This is an old cache can be, and that leads to inconsistent data. So another disadvantage point is complex locking system, we usually call. It means a shared disk set up, multiple nodes can try to update the same data at the same time. The problem is if it is a single server, they can communicate easily because everything is just a single run, as we for example talked before in this shared memory. But in this case, the shared disk, they are separately machines, and it means logs must coordinate it over the network. They can work parallel. They cannot work parallel. Like, for example, node A and node B we have. When node A works, node B must wait it, because it usually logs the process after the finish. So it can share them in other nodes after the finish. With a simple analogy is like in the single DB, one room, one whiteboard, no? And the shared DB, many rooms, but one single, for example, whiteboard, like the Google, for example, collaborated Google Docs. When we have to check over the internet, like is some editing this, is some editing this, is some, for example, updating this, is some saving this, like this, drawbacks we have. So this is the main concept of the shared disk technique. So the last technique is shared nothing. So the shared technique, so It's a distributed computing technique and architecture where each node is a cluster, acts autonomously and processing in its own CPUs. It includes its own disk, its own memory, and its own cache, and of course, and its own database as well. So the main idea is each node is allocated separate RAM, separate disk, separate CPU, and all of nodes communicate each other by only the network. Its another name is sharding, we can call. So how it works? So firstly, client sends some kind of request. We can say, for example, in here some client we have. It sent some kind of request. So firstly, query comes to the node, of course, and after the node, CPU checks the memory firstly, like is this data in the RAM? If yes, returns immediately from the, for example, cache. If no, it usually sends a request, for example, to the disk. And it reads from the disk and save the memory. And inside that CPU process, like after the filtering, after the building the result, and the after all returns the result. Simple analogy is our just laptops. We can give as an example. CPU is our laptop's processor, memory is our laptop's RAM, disk is our laptop's SSD or the chip. They don't depend on each other. So shared nothing technique is the best for huge scale projects, and mainly this is a modern internet architecture, we can say, like Google Search, AWS, like Amazon Web Services, and so on. These techniques' advantages are firstly the big scalable, high available, and difficult consistencies. All of these nodes are the same data at the same time. And of course, there is some kind of drawbacks, of course, like data distribution challenges. Here, it means how we need to split the data. For example, in here we have a main data like data distribution challenges. It means how we need to split the data, how we need to, for example, store the data, which data stores in which part. Means like we need to load balancer design. So in fact, actually this is normal for such drawbacks to occur in the system design. The main goal is to run the project with the least possible drawbacks based on our business logic, of course.